In this lecture, we're going to look at setting up our third and final game setup, project setup. And we're going to do that by starting with a somewhat more advanced project than what we've been working with so far. So rather than the templates, we're going to go take a look at the Epic Games content here in the marketplace. So I'm under the Unreal Engine tab normally, and we're looking over here for our environments. We're going to be under here in the marketplace, so you're going to need to go over here. And you'll want to go to the Epic Games content specifically. You can't search for this. If you try to search for the Action RPG without it, then you won't find it. So if we scroll through here, I'm not going to try to show you what page it's on, but we're looking for the Action RPG because I don't want to show you what page it's on because it might change depending on what day you decide to look at it. So rather than relying on that, just make sure you work through, you're going to be in the Epic Games content, you're going to go scroll through until you find the Epic Action RPG Starter Kit here. And you'll want to add that so that you're owned and move on. Now, while we're here, we're also going to come back and look at some of these Paragon characters later on. So keep this in mind. These characters are also all free and available, and you are going to add them to one of your projects later on here. Now I will show, so if we do search for Action RPG up here, unfortunately we only find something that is not necessarily, I don't know that this is necessarily a bad product or anything, but it's not the Epic free content. And so they don't put that in their search set. So unfortunately you're just going to have to go find it yourself. Okay, and then once the Action RPG project is added to your collection, so you've clicked to purchase it as a free asset, it will show up in your vault, and so you can see the kinds of assets that have shown up that I have here that are available. The book describes using this animation starter pack, for instance, so you may have already pulled that one. So you have two options when you're using these. One is to add them to an existing project, so they become new materials that essentially new content that you can then use within that project. Or in the case of the Action RPG, it's really a separate project. It's much like the templates we've already been working with, but we had to pull it from the store, so it's not necessarily going to be in our startup, so it's easier just to create it here. So we go down to the vault, we say create project, and then I'm going to cut to make sure it shows to my my location here, and then I'm going to say Action RPG project for this case. And it really doesn't matter what you call it. Remember to set your version, choose the version that you've got. It'll probably be there by default. Pick a name that means something to you, and certainly make sure that you store it somewhere that also makes sense to you wherever you're saving your assignments. Um, but that will be up to you. So then we'll create that, and it will take as long as it takes to come down. Okay, so thanks to the magic of editing, we now have the project. Yours probably took a little bit longer to come up than what you saw here, but of course mine did too. So by pressing this button, we created the Action RPG project, and you'll see that there's a couple here. But this is the one that I created. Yours, of course, will be named whatever you named yours. So let's open that up and take a look. And so what we see here is something far more complex than maybe what we're used to in terms of what we've seen in the past couple of projects. But at this point, you should start to feel comfortable looking around, clicking on things, understanding how to navigate, understanding how to at least explore the materials and what's happening with the various pieces. And then we'll go further into understanding some of these volumes and the way they are blocking out the nav mesh and creating boundaries for the level. And we'll also look at some of the other lighting tricks that are going on here as well as, of course, the AI, which will be the next piece that we move into again. So before we get too much further down that route, let's go ahead and take a look at what the game is like. So we notice at first there is a full intro action sequence. We're going to strip this out simply to make our jobs a little bit easier in terms of being able to start testing the game very simply. You'll also notice that this is a wave-based, like a horde mode kind of game, right? Where we end up with hordes of enemies coming after us, and we have to survive the waves and so on. And what we're going to do with this game is we're going to strip out a lot of the basic mechanics here and make something a little more stealth, a little more constructed. And so rather than having the creatures spawn in waves, we're gonna pull that out and instead have them exist within the level doing a similar kind of AI to what we were doing previously with the state machines, but we're going to do it with behavior trees instead. Um, and we'll look at both spawning new AI and as well as having existing AI within the level, and we'll expand it from there. So let's take a look at least stripping back what's here and understanding what we're kind of playing with to get us prepared for going back into expanding on what the book is making available to us. All right, so let's bring up the world settings window, which looks like this. This sets up a game mode as well as what our default pawn class is, what it's going to create for us. And so we can go and find these things and see where they exist in the world and take a look at them. So this is maybe the first time that we've started looking at this. This is actually overriding quite a few of the things that we're used to. And in our case, this BP game mode here is where it's overriding the startup and creating this whole start sequence. So let's go ahead and open that up, and we can take a look at where these things are happening and also strip out some of these processes. So to begin with, this is we get an event begin play inside our game mode blueprint, much like we do with our other elements in the game. And we find if I double click this play default cutscene, this is the full set that takes care of creating that initial montage, right? So it's goes through, sets up, all the variety of things we want to have happen. We're not really going to explore that necessarily here. Instead, what we're looking for is the fact that we want to see this start game. So the start game is really the one that we want to go to immediately. So instead of doing that, we are going to break the connection here. We can save it and keep that node around in case we want it later. Instead, we're going to call start game. So this will take us directly from pressing the play button directly into start. And then if we go take a look at the start, and again I'm double clicking to look at these events in action, we see that we both restart the player, which in this case sets up the player's initial mode and everything and creates us. But it also starts a timer and the enemy. And so for now, we're going to go ahead and remove those as well. Technically, we could get away with removing that one line, but let's remove both just in case. And we could look at potentially coming back and maybe spawning some enemies. We will be spawning enemies later, but we will not do it necessarily by a timer. We're going to do some other activities based around what the book is guiding us to do in this case. Okay, so let's take a look and see that this is doing what we expect. So we start out and we note that we're no longer going through the montage here, and that there's a timer, but it's not counting down, and there are no new enemies. So now we have an empty level that we can explore. We can take a look at what's happening, and this gives us a workspace to start modifying. Now at this point we are tracking along with the book, chapter 5, or at least we're going to somewhat follow along with what's happening in that book. So to begin with, let's take a look at the nav mesh. So the book describes creating a nav mesh volume to begin with in order to traverse the level. We'll take a look at what's here and then talk about what it is. So pressing the P key in the main scene window here brings up what the nav mesh is. And what we're seeing here is the boundary of the mesh. Now you see a couple of interesting things. One is that there are these volumes that cut into the mesh, and they are blocking volumes intended to mean that you cannot step through them, right? So technically, we can actually be inside the volume, and we can be outside the volume, but we can't traverse over, right? So we can only really follow contiguous regions of green space when we're doing our pathfinding. So recall what our discussions about pathfinding and searching through node to node. And what you can imagine here is that there are sort of open spaces that are defined by nodes. They're actually triangles. So this space is cut up into triangles. We can't necessarily see that, but we know that they're there. And what we'll do is find points in the triangles from triangle to triangle that move us through the space, and we'll use the A-star algorithm to find the shortest path possible. In fact, the AI is going to do that for us. We're going to just tell it to move from point A to point B. It's going to find the shortest path possible. to get around. So it'll do things like move around these corners here or around other obstacles, and if there's no path, then of course it'll find nothing. Um, so the way that this is defined is there's actually a volume around the space itself. So if we click on that volume, we see that it captures pretty much just this level space, and if we wanted to, we could make it, say, larger by modifying its height. So we'll modify the height, not the width. And what we'll notice is that in some cases this might actually start finding other regions that we can walk onto, right? So we've now created a nav mesh on top of this area of blocking volume, which might not be something we want. So you of course set your volume based on what you want to do, and you could potentially have multiple volumes if you need. But this will let us define the region that we want. So as we look at expanding this level and making it larger, moving things around, one of the ways that we can start to allow the AI to exist in further regions is simply to make the nav mesh volume larger, and by extension then have more space for them to walk. So for instance, I can change this Y value here, and I see that when it updates, it shrinks the amount of walkable space. So now they can no longer walk in this corner at all, or maybe that corner is important to me, so I'm going to make sure that they can walk all the way to the edge of that corner. And of course, they really can't get in there because we've got all of this region blocked out. Okay. So now, in addition to modifying the nav mesh, we also may want to be able to modify the terrain, especially as we start to expand the level and move things out. So, so a lot of the base level here is actually terrain, and so we see that it creates a square, and potentially we can make this larger if we wanted to. But let's just take a look at the simple painting that we can do here to modify it. So so we've seen some of the so we've been spending all our time in maybe the object mode over here, but let's take a look at the landscape mode. So there is some ways that we can manage the terrain itself, but let's start with the sculpting here and take a look. So what we're doing is modifying the height map. So a terrain is a way of turning a height map into a set of triangles, which are rendered somewhat optimally. But you can think of the height map essentially as, if I start to modify this, so if I'm going to paint and make some of this larger, I'm adding height, and what's happening is that it is automatically putting triangles in here to fit the structure that I'm trying to create. So you might be familiar with, or you've seen maybe games that do voxel methods as well, something like fancy Minecraft, where you can paint or just add to or destroy the terrain with like a terrain modification tool, right? So we're kind of doing that, but we're doing that as the editor ourselves, right? So we are coming in here and changing the height. So we can do that. I can shift-click to reduce the height back down. In fact, it mellows it down to nothing, and if I continue to paint down, I can drop it below the earth. Some of these structures, of course, are not nav mesh. They're actually extra pieces in here. Things like the leaves here are actually a separate object, right? That was actually created to add in here. So this is often the way that we do, especially outdoor scenes, but also just in general, manage the complexity of both, right? So we're adding some objects that are actual objects in the scene, and you even see that these objects, we're seeing only a small piece of it, like the glacier that stunk the Titanic, and as well as a mix with the terrain itself, right? As well, and then the things that are on the terrain. So you can use these things as a combination, and what's nice here is that we could even, take a lot of these pieces and copy them, reuse them, move them around, and rebuild our terrain. And then in addition to being able to sculpt the terrain itself, setting the height and everything, we also have the ability to paint textures, paint materials onto the terrain. So this process is known as a splat map, and what happens really is that at every point in the terrain, we are picking and choosing levels of material between the three materials here. So we're saying essentially for it to do a blend and a linear interpolation to paint a little bit of this color and a little bit of that color and a little bit of that color, but some of them might be set to 0, right? In the case of wetness, this no weight blend means that it just simply either overrides or rides what's in there. So with the first two, I can paint, and I see that as I paint the mud texture, it starts to look muddier. Come back through, and I paint the cave dirt, then it looks this way. As I paint the water, in this case, it looks significantly different. We're getting not only a reflection to the water, and of course a region here where we're putting water in a bump, which probably didn't make any sense. But we also get like a small animation texture as well, so a normal map offset, or an animated normal map that is causing the reflection to be varied, right? But in terms of what we've seen with materials, this is not too much different. Now to unpaint the water, I would come through and shift click, much like I would to reduce the height of the terrain. And for the purposes of this, it's not necessary to worry too much about about the details of the structure of height maps or splat maps, but to understand that you do have these three materials available, you can modify the height and then paint new textures. Now, as the last little trick to expand the terrain and make it larger, let's zoom out a little bit. There's a number of ways to actually modify terrains. We could potentially add sections over here, but we're just going to change the component size here. We'll have links to describe the terrain process in more detail, but in terms of just being able to expand at this level and play around with things, we'll simply start by setting it from a 1x1 texture to a 2x2. And you'll notice that what we have is that this block that we had in here was divided into 63 by 63 quads. And so our height map was actually a 63 by 63 mesh, and we're modifying those individual pieces, and that's where the triangulation is coming from. And what we're going to end up doing is multiplying that by 4, so we end up with a 127 by 127 with two new sections, right? And so doing that, we essentially quadruple our space, and it gives us quite a bit more to work with in terms of both painting and sculpting as we go. So we can come back out here, and now we're able to come through and do our sculpting as we were before, right? And come in as well and do the painting out in these regions. So this, in addition to being able to then move the blocks around or copy them or whatever it is we want to do, we can structure our level. And the one last thing to mention before we take off from structuring the level completely, other than taking a look at the clever use of all these things, is to make sure to update the size of our height block, or of our light blocker here. So this is really setting a boundary to the level itself. We can also look at the light mass importance volume as well, and we'll go back into more depth on lighting elsewhere or later on. But for now, we can just set these to much larger and make sure that they fit the bounds of the level or are centered to the new bounds of the level that we're working with to make sure that everything fits like we'd like. And of course, very importantly, don't forget before you move on to also set your nav mesh volume. So again, we'll put out our just press the P key to draw the size of the volume, and we will set this somewhat. Oops, that's maybe a bit too large. Yeah, so I've maybe made this unreasonably large, but that's okay. We still know that our level only goes this far, and we can still play with the blockers. But again, make sure you manage all your volumes as you see them, and we will go into some of the details on each of these as we go through. Okay, but let's move on. At this point, let's go ahead and start moving on to the remainder of the book chapter and actually create agents to fit within here. So I'm going to build a folder here to store all our work. I'm going to just call it project. And then I'm going to create a blueprint class, and we're going to do something a little different than normal. We're actually, rather than creating a blueprint based off an actor or a pawn or something like that, we're going to use the goblin, which is one of the characters that's already in here. And so what we're doing really, this goblin is already a blueprint, and we're going to build our blueprint off of that. We're going to inherit that, and so we're going to inherit all of the properties from it. So let's call it Smart Goblin. And let's take a look at that to see because this is kind of our first real experience with some inherited properties for everything. So you see everything's listed as inherited. If we go take a look at the construction or the event graph, we see that what's happening here essentially is that we have a begin play that belongs to us, but there's also a parent begin play. And so those of you familiar with inheritance, this is how we start to call into our base class, right? So sometimes you'll override a function or use polymorphism to change the nature of a function. Don't worry too much about the term polymorphism or any of that. Really all it means is my parent had a begin play, I'm going to create one, and I might do something different. But then I also might want to add on to the parent. So I might do like very simply, my entire begin play is to print a string to say hello, and then everything else beyond that just does what the parent does. So because the parent has one, I can call it, and then it'll do my execution, and then it'll do everything else that's there. So sometimes you want that. Sometimes you want to overwrite it and say, no, I don't want what the parent did. I want to do my own begin play. So I'm going to inherit everything, but then I'm going to completely replace the begin play. So those are the kinds of things that you start to do when you use inheritance. And of course, the reason being that you've, as we sort of talked about in earlier on lectures, you might create a sort of base enemy kind of class, but then your specializations, as you go further down and inherit, you might create like an ancient enemy or a more powerful version of your goblin. So in this case, the goblin that we had was dumb, and we're going to create a smarter one, right? So the goblin that we have in this game by default just runs towards the player, and we're going to have one that will move back and forth and do the same things that we were doing in the state machines and other work, but now we're going to do it here using behavior trees instead and with fully animated graphics. Okay, so let's go ahead and put this back before we get too much further, and I'll actually go ahead and just get some of these ready to go for later. Now, a reminder as we start looking into this, everything we're doing now is back more aligned with book chapters 5 and 6. So if you're wanting to follow along or get, again, the extra details that are mentioned in there, that's where you want to be taking a look. So we're going to go ahead and create some artificial intelligence assets, and we'll kind of go through behavior trees as we're doing this. But what we're going to do is build a behavior tree that is that follows the kinds of state machines that we've seen previously. But in this case, it's going to be done as a behavior tree, and we'll understand how we'll look at how behavior trees sort of treat the whole state process separately. So we'll say goblin behavior here. So the behavior tree is sort of the algorithm or the brains. We're also going to need a blackboard, and the blackboard is the way that we'll call that goblin BB. The blackboard is essentially a mechanism, an AI mechanism for capturing data. So it's kind of a generic way of putting information onto the blackboard, and then anyone who wants to can read from the blackboard and get the information they need. And so often there's different subsystems that might be reading or writing to the blackboard, and so it's kind of a way of coordinating information. But really, it's just a global variable space. It just happens to be done in a way that's usefully generic. So we're going to do our second inheritance here, and this time we're going to create a blueprint class, but this one is going to be based on the AI controller. And the reason for that is this, as you can see in the explanation here, it's for controlling a pawn. And so the smart goblin is a pawn. It's actually inherited, it's the NPC goblin is based on a pawn, and then our smart goblin is based on the NPC goblin. And so therefore we have a pawn, and we can be possessed by a controller. So it could also be that you could change the controller to the human and have the human control the goblin if you so wanted. But our controller in this case is going to be the AI controller, and so now we're letting the AI take over control of this character and move them around. So that's the notion that we're going for here. So we'll go ahead and call that, and we'll also just make that the goblin controller. So actually, let's go ahead and set that up now. So I'm going to go take a look at the goblin, and if I scroll down, then I see in the section here for pawn, I see where all the possessing takes place. So I can see that auto possessed by player is disabled. That's because we've got an AI character, and in this case, it's already set up for us to have an AI controller because it's based on the previous goblin character. But we want to replace it with our own. So we're going to do that. We're going to come in here, and And so because our Goblin controller was inherited from an AI controller class, then it is an AI controller to some degree. It just has its own specialization of the kind of AI control. And so we can replace it in here. And now any changes that we make to our Goblin controller blueprint will then be applied to this. And so that's going to be the one that now controls this character we put in the world. And that's both the case for whether you place it or you spawn it or otherwise it's disabled, right? So if you don't want AI control, you disable it. I can't say that I would ever understand why you would choose anything other than placed or spawned, but maybe there's some specific instances where if it's already in the world, you don't want it to have some control or vice versa. Can't imagine those scenarios. But it's a fairly interesting sort of setup here in that really what we're doing is kind of creating an AI that does the same kinds of things that a human would do in terms of interacting with this character, but now the brains are a state machine or a behavior tree. All right, so let's start building out essentially the same state machine kind of stuff that we were seeing before. So we're going to create 2 control points. We're going to come zoom back into our much smaller view of the world for now. You will have the opportunity to expand this later on your own. It's an exercise. But let's go ahead and find our target point here. Oops. And set up a couple patrol points. So we know that our players spawn somewhere over here. We can find the spawn point, but we're not going to worry about it. And so let's just set up a couple target points out here in the world. Now we're going to change it up a little bit in that, let's go ahead and just call it patrol point 1 this time. And vice versa. And we're going to add a sphere collider component to this. And the reason for that is that we're going to actually use that sphere collider to help us determine when the AI is close enough. So we are no longer necessarily steering this ourselves. We're going to rely on the path finding and path following steering behaviors that are built into Unreal. And so now we kind of want to know when we're getting close and when it's a good time to turn. And so we'll use the sphere collider to help us do that. So we'll leave it at 32 centimeters for now, and we might tweak that later if we find that maybe we want something a little better, right? But our default size here, as you can see, is 32. So then, just to simplify this, we'll go ahead and duplicate it, and we'll move this guy, our patrol point 2, somewhere further away. Let me grab it and move it here. Okay, so now we'll have our goblin move between these 2 patrol points as we go. Let's go ahead and set up our communication chain. So we'll start by opening up the goblin blackboard here. And if this sub window isn't open or the subtree, then go ahead and open that up. And it shows BB base as our blackboard to start with. We'll go ahead and set goblin blackboard instead. Because that's our new blackboard and we'll have keys associated with that. So we'll set up a key here and we'll call it, we'll make it a type object and we will change the name to patrol point. And then rather than an object specifically, so we need to, it's a type object, but we actually want an actor. And the reason for that is that actors have a position in the world, and we want to be able to go to that position as part of this character. Okay. So then over in our Goblin controller, so we're going to come over to our controller, and what we're going to do is tell it to run a behavior tree. And what this does is sets up to say that this controller is responsible for running this kind of behavior. So this is the brain we want you to run. You're going to run that the whole time you're running, and so on. So now we have a connection between our controller to our goblin, because the goblin is going to possess, or the controller is going to possess the goblin, and then we have the blackboard. So over here in the begin play, we can come in. We can say, get a reference to self that way. And I will get my blackboard this way. So now, given that I have the blackboard component, and this is going through and finding the blackboard for me by capturing the fact that I'm a pawn, it's going to query my controller and so on, and get a hold of that. And what that does is then with a variable here, and I'll go ahead and set up that variable now. So we'll have a current patrol point, which will be an actor. going to set a value as objects. Let's make some room. We'll get our current patrol point, and we will also make a literal name. And this name needs to match up with our blackboard. So I'm just going to cut and copy here. I'm going to say patrol point, and then copy that in. So what we're seeing is that on initialization, then I am going to set it to my current patrol point, which could be either one of the two. We'll be happy with it. Let's finish out this this section here. So we will call this patrol. We'll create a patrol point 1 and a patrol point 2, and this should start to look very familiar to you. So I'm going to make these public variables. In fact, I'll leave that as a private. We'll just set it over here in a second. And I am going to, let's go ahead and put an instance of our character in the scene so we can have him out there and start to move him around. And what we'll do is set up the variables over here. So we'll find patrol point 1 and patrol point 2. And then in the beginning, up here, we'll just go ahead and set current patrol point. And I'm going to default it to patrol point 1. Okay, now recall that we set up these patrol points to have a sphere for overlapping on them. Right? We'll check the collision and see that we do have set to overlap all dynamic. So that means that we can come in here and say event overlap after begin overlap. And what we'll do is we're going to compare who we're overlapping with and see if it's patrol point 1 or patrol point 2, and then we'll set the current patrol point to one of the other ones, right? So what we'll do is we'll say branch, and we'll compare and so if we're overlapping patrol point 1, then we will set current patrol point to patrol point 2. Otherwise, we'll set patrol point to patrol point 1. Actually, I'm going to take this a little bit further, and if we're not doing that, I'm going to do a safety check, because we might actually overlap with more than just that actor, and we wouldn't want to have a bad condition there. So I'm going to do this, and then I'm going to suggest you look at that as an exercise to understand what's happening. Of course, this is how the book does it as well, so I'm not doing too many surprises, but you can certainly take a look at the explanation there. But it's worth trying to understand the difference between what could happen in the false case if we're just comparing against patrol point 1 or, versus patrol point 2 and so on, and understand that there are many actors that we might run into or overlap with in the game, and so we want to make sure we get the right ones. And then the last thing I'm going to do is I'm actually going to cheat a little bit, much like we see in the book, and I'm just going to set the execution path over here. And so what happens is, much like we do at this beginning play over here, we set the execution path and it goes and queries to get our control point. Well, as soon as we set the execution path this way, then we've set our current patrol point, and now we're just going to use that to set our blackboard value. So this is going to keep the blackboard value up to date. So let's go ahead and set some comments to keep all this in line. Okay, great. So we've kind of done what we need to do here. And this sets the stage for us to do the remainder of our behaviors, or many more of our behaviors. So you will note that we are kind of hiding some of the state. We divided this out into a state transition in previous discussions using state machines. We actually used a separate state transition, one for patrol point 1 and one for patrol point 2. Here we're going to have a single state to capture patrol inside the goblin behavior, but in the behavior tree. But in here, in the controller, we can keep track of where we are using the fact that we know about the collisions over here. So the behavior tree really doesn't understand things about actors in the world. It really only understands the world in terms of the blackboard that we're passing in. And so that's why we're kind of doing a lot of the work here and then passing it in through the blackboard. So it's a different way of thinking about things a little bit, but certainly blackboards are also something you can use in combination with state machine as well. So we have our connection set up. We're initializing the blackboard. We're setting up the moving between the patrol points. We have our goblin controller telling us we want to run this goblin behavior. So let's see what state machines look like when you're doing them in behavior tree style. So really it's no longer a state machine, it's actually a behavior tree. So there are two main nodes in a behavior tree that you use. Actually, there's three. So there's two main control nodes and then an action node, and we'll see what those look like. So first, let's get a selector node, and the selector node says I'm going to run each of my children until one of them succeeds. Okay, so we assume that every task has two options. One, it can either succeed, or two, it can fail, right? As most tasks do. And so the selector says, given all the children that you might, all the actions or composite actions that I might want to do with my selector, I'm going to try to run them all until one of them succeeds. But it's going to do it in order, right? So we're going to actually put a sequence in here. That'll be action 1, and we'll look at that in a second. And then we'll put another sequence over here, and that'll be action 2. And actually they're labeled 1 and 2, but technically we've actually got the node 0 up here as well. And so what happens is it'll come through and it says, okay, start selecting. And it says, try to run this sequence. And if this sequence fails for some reason, and we'll talk about that in a minute, then it'll try to run this sequence. If this sequence succeeds, then the selector returns and says, I succeeded. Right? And if this sequence fails, then it tries to run this one. And if this one succeeds, the selector returns and says, I succeeded. Right? The root doesn't necessarily care, but you could potentially have something containing the selector, right? So then if this sequence fails, then the selector returns, I failed. All of my children failed, so I'm failing as well. So you can imagine putting the selector in even a higher level chain, right? So the root at the top level just says, I'm going to run something underneath me. I can hold one action. You tell me what you want that to be, and usually it's a container, right? So the selector is one type of container. The sequence is the other main type of container, and that says, I'm going to run everything in order until one of them fails. So where the selector said, I'm going to run them until one of them succeeds, the sequence is the opposite. I'm going to run them until one of them fails. So if I've got action 1, I'm going to run that one. If I've got action 2, I'm going to run that one. Action 3, I'm going to run that one. If at any point any one of those fails, then it stops going in order. And again, it goes from left to right. So it's all graphically set up here. And so if we have several things going on, then as soon as one of them fails, the sequence stops and then they fail. But it will have run a certain set of actions up until it fails. Okay. So then it fails, and then it comes over here, and it'll do the fallback because we've got this whole selector happening. So we're actually going to do something very simple and kind of obvious, and we're just going to say move to. So we're not actually doing a full sequence. We're just doing a simple action. So technically, I could do this, right? So I could say, actually, I want move to be the selector here, and the other action we're going to do is idle. So we're going to say wait, and we're going to wait for, we'll call it 5 seconds. So if for some reason you fail to move, then it'll just sit there and wait, right? Now notice that the move to actually succeeds by moving us to our patrol point. And also actually notice that it selected the patrol point because it's going to try to find a blackboard key as its move to target. And so in this case, the only key that we gave it is the patrol point. If that patrol point was set to like a float or something like that, we'd pretty much just have an error here because it wouldn't know what to do with a floating point value or whatever other kinds of things we might have passed in as our blackboard key. So with the patrol point, it finds that and it says move to. Okay. So let's go ahead and we'll save this. Actually, I'm gonna put it back. So I'm gonna copy the book. The book puts in simple sequences here. So we've got a selector to go to the sequence and a selector to go to the move to. And the reason is that we're going to do more complicated sequences down the road. So we're not going to start with the simple structures. But you'll notice as you start to observe behavior trees and as you start to look at the other behavior trees that are built into the system, what you're going to find is that this is kind of a common pattern, actually, that you have a top-level selector that says, I need to pick some kind of task to do, so I'm going to figure out which one of my tasks it's going to be. It could be the patrol sequence, and in fact, let's go ahead and call that the patrol sequence. It might be the flee sequence, right? If our selector said, well, we tried to patrol, or actually it works the other way. You end up putting the flee over here, and it says, if I've got low health, then I'm going to flee. And if I don't, then if I fail to have low health, then I go over here and use the patrol. We'll see that in a minute with the attack. Or you might say one of these sequences is the attack, right? So this idle here is really going to be our don't know what I'm doing. If all else fails, I just sit around and wait for a minute and see if the world moves into a place that I can understand it. So just stand still, which is a good thing to have as a fallback, because then you know what's going to happen. But you have that kind of pattern often, right? So you have at the top level, you say, I'm going to select something to do. I'm going to start going from my leftmost, which is usually my highest priority of interest, and so probably the attack would be over here, down to the lower ones that say, all right, if all of these are failing, if I can't attack and I can't flee because I don't actually care about fleeing, all right, then I'm going to go do a patrol. Okay, so that's actually what we're going to start to build out. But before we get there, let's test this out. So this is all we needed to do to create this sequence. The move to is doing a lot of the work for us. So again, recall now that what we're taking advantage of is not just the fact that we put this together to say, let's go ahead and save out a lot of these things here. We didn't just put in a controller to say run the behavior and go figure out where the patrol nodes are. Certainly we know how to do all that by now. But importantly, we are using the fact that we set up a whole navigation mesh, right? So this whole green mesh is here. And so underneath the hood of this one simple action, and this is one of the actions that we're looking at, is the move to, and there are many others that we could have selected from, so we can see all of the possible tasks. I guess Unreal refers to them as tasks. They're actions or tasks. We have a number that have already been set up, making noise, attacking melee, so on. We're going to make our own in the near future here. And the move to is saying, I am a character, right? I'm an actor, I'm a character. That means I actually have a skeletal mesh. It means that I can move along the world. It means that I can follow, very specifically, I can walk along a nav mesh, and I should walk along a nav mesh, and I should stay on the nav mesh. And I shouldn't go through areas where the nav mesh isn't. So when we say move to, we look in this case and we note that our patrol points are kind of here, and the straight line distance doesn't necessarily put us over here. In fact, I'm going to modify this one and say it has to go around the corner, right? So what that means is that we're going to have to pathfind around this rock. And so we're taking advantage of the fact that that move to is actually going to do the full pathfinding for us, and it's going to do all the steering as well. So this action doesn't necessarily run just in one frame. This action runs until it's done. It's decided either, so really an action or a task has kind of three states. We said that they really only have two. Technically they have three states. One is, I'm currently executing, so get back to me later. Two is failure, and three is success, right? So the move to is usually going to be, I'm trying to figure it out, get back to me later, leave me alone, I'm trying to do my thing you asked me to do. And then the second one is success. But sometimes you might actually be able to fail in a move to, depending on what happened with the world or what's caused you to fail to reach a target under certain conditions. And in that case, if you actually fail to move, then you fall over here and you'll sit around and say, I don't know what I'm doing. Right. Okay, so let's test it out. Let's see if bringing this character in actually works. So we see him moving back there. He's going to ignore us because he doesn't know anything about us. And we see that as he gets close to his patrol point, then the goblin controller kicks in and says, change the patrol point and change the value on the blackboard. And so because of that, then the move to gets updated, right? And so it runs through, it says, I succeeded, my selector succeeded, I returned success, I went back up to the root, and I'm starting over. So actually, while we're looking at that, let's go ahead and see what the goblin behavior looks like. Oops. So while the goblin behavior is running, we see that essentially we're just walking to the selector, and we're walking to its patrol sequence, and we're walking to its move to. So again, it's not a very interesting scenario, but what's useful to know here is that we can reuse this much as we already did with looking at blueprints and watching those activate and so on. In fact, let's go ahead and highlight our goblin and see if we can watch the blueprint trigger as well. This one might be harder to do without a breakpoint. We do see the event tick happen. Yeah, so we see the actor overlap fire off when it hits the patrol point. We'll see it again here in a second. When it hits the other patrol point, it'll fire down this line. And so we can use all of these things to debug and watch our behaviors. And this becomes kind of critical, especially as we start to get very complicated behavior trees. So this is very nice to have. And as we've worked with state machines so far, hopefully you feel a sense of this feels, in some cases, it's a little new and confusing. It's different than a state machine where you can just say, I want to be in this state or that state. But it's also quite a bit easier to structure some code in some ways. And so if you, hopefully you can look at this and start to kind of understand the trade-offs between building a state machine and even just building a state machine, because these are in some sense complicated state machines here graphically, or building a behavior tree and where the trade-offs are in some of these things. Moving on, let's go ahead and add some complexity. So we're going to go ahead and follow the book with this one, and what we're attempting to do is when the goblin sees the player, we're going to have them chase the player down and do an attack. So now the book does something a little weird, I think, simply because we are setting values on the blackboard here, but we're also we're going to end up setting values on the blackboard here as well. And there's some ways I like that. It sort of makes the blackboard kind of apparent, but it's also a little strange to have it there. But we're going to go ahead and follow the book because I don't want to deviate too far. But just know that you can actually do this kind of thing elsewhere as well. So, or in multiple locations. So the pawn sensing pretty much acts like eyes and ears, right? So we have values for hearing sensing and sight radius and whether or not we need line of sight. Actually, I think we always get line of sight. And at least for the sight, we're always going to see it, and later on we'll actually see the noise as well, or how to hear. And this is a pretty good system for being able to see and hear. And so you might look at this as, this is where the intelligence is, and this is a good place to have those things occur, right? The fact that you're seeing or hearing as a player, you would also see and hear an event happen. But you might also, maybe it belongs on the character, right? So you might think that the sensing actually belongs over here, and if we were to add it here, it would work as well. The thing that's happening is that we actually end up, because we're possessing the pawn, our location is much the same in both cases. We're actually kind of moving in another case. So again, we're going to follow the book, but just to understand kind of what's happening in terms of the model of the behavior that we're going after. So we're going to add this on-see pawn event. So this is something a little bit new now, so let me call that out as well. So we've added this component, and we have these events down here, and we've actually sort of taken advantage of this in the past, the fact that the events are there, but I wanted to draw it out to the fact that we've now added this capability, and we're actually pulling it in from over here, right? So normally we get the collider, we'll add a collider, and we'll be able to then do the on overlap because of that. Now we haven't necessarily used it that way all the time. We actually use it on the main character who already had the ability to overlap. But that's kind of how this works, right? So we add a component, and then that gives us some new variables, some new behaviors, but also some new events that we can then take advantage of. So this one is, now triggering off the on-see pawn, and when we do that, we're going to want to set a new variable in our tree. So let's go ahead and set up the variable so that we have it ready to go. We're going to do yet another object, and this is our target. And it'll be an actor again because we're actually going to move to the target. So we'll need to go down to the key type, or the base class here. Make sure we're setting the right thing. save that out, and then back on my controller, go. So we'll do another one of these set values as object. Actually, I'll just leave this up here. The value we're going to set over there is the pawn and the key name in this case. I'm going to go ahead and cut and copy it again. Make sure I've got it exactly right. Now we need to add our attack behavior. So we have our target set up, or we should have it set up. So let's come into the behavior tree here. We're going to add a new sequence node. We'll go ahead and give that node, or that name to attack target. And we're going to use a new type of node here. So we mentioned that the selector, or I mentioned earlier, the selector will try to run each of these in order, and so we see that, we see 1, 2, 4 in this case, and again the numbering kind of goes down that way. But we know that they're going to run from left to right, so we start first with the attack target and try to run, and then we'll do the patrol sequence. So the first thing that we're going to do, so that the decorators are a way of modifying a node to say whether or not we want that node to change its normal behavior. So under the normal circumstance of a sequence, it's simply going to run. And so one of the easiest and sort of most used decorators that we'll probably use are to check a value within the blackboard. We're going to check to see whether or not a value is set. So we'll take a look and we'll say, is the target set? And then based on that, we'll go ahead and change the name here as target. Right. So this decorator says, under normal circumstances, you would just go straight into the sequence and start running and trying to do the attack situation. But instead, before you even run, I'm going to check to see if target is set, and if not, then I'm going to return false for you. So given that, then this has target sets up a condition for when this is going to run. So rather than simply always running the sequence, trying it out, and then failing to do the selector process, it's just going to check the decorator before it moves on. So there's also then kind of a bonus action that we can do here, and that's that this ends up being an observer, right? It is taking a look at the blackboard and checking it kind of constantly, and so it'll do a notification whenever the result changes, or whenever the value changes, result, whatever. Actually, I don't know exactly what the difference between these two is, but I'm not too worried about it because we'll just leave it with the default. I think in this case it's going to be exactly the same result, or same effect. And then what we want to look at is aborting. And so we can abort none, which means that nothing stops running. We can abort self, which means that we need to override our own situation. Like maybe if this suddenly turned false, we need to stop doing what we're doing. We could abort lower priority, and that's the one we're going to want, or we could abort both. So if this changed, we need to kind of just reassess the situation entirely. So what this means, abort lower priority when the result changes. So when we're going to switch from false to true, based on the fact that the target is now set, it means that it's going to tell these to abort. It's going to tell these sequences to abort. So the only one that we're really going to be in, and we already saw this, is we're going to be in this patrol sequence sort of forever, right? It was just kind of hanging out here. And so it's going to be in this lower priority sequence. So we've kind of already gone in by the time we get into the patrol sequence here and said, oh, I didn't have a target, so I'm failing, right? And if we didn't put the abort in there, we would wait until the move to finishes. And if you recall, the move to has 3 results. It's running, it's in the process, right? It's failing, or it's succeeding. And so if it's in the process, there's nothing that's going to stop it from moving until it gets there, unless maybe you can block it or do something like that. But it's definitely not going to stop just because it sees the player. And so that's not really the behavior we want. We don't want him to just continue on his patrol path, hit the next patrol node, and then stop and start trying to deal with the player. We want him to immediately stop wherever he is in his patrol point, whether or not he's hit the target over here, and immediately start doing this, start moving to attack. So that's why we have the abort lower priority here. So this means that no matter what's going on over here, it's going to stop and pretend, like tell the selector, you need to just start over. Like we quit, everything's changed, you need to start over, come down this path and start running because my whole result has changed now. Okay, so that's the idea here. So let's test that out. We're just going to set up a second move to at the moment that all it does is, we're going to move to the target. We're not going to move to the patrol point, we're going to set it up to move to our target. So now this is, once we've sensed a target, then we will abort our patrol sequence and move into the attack sequence. Before we get too much further along in this sequence, I'm going to do a couple of things. One is, in order to test this out, I'm going to put a little bit of a wait state in there. That way, one, we know when we think we've arrived at our player, so we'll put in a little wait of 2 seconds. That kind of stands in for our attack as well. And then I'm going to create a new task. So I'm going to create one based on blueprint base, and you see that there's other potential tasks we could build from. These are all tasks really that are part of this attack set. So we're just going to build one from a blueprint base, and this is now a specialized kind of blueprint. So what we're doing now is really creating our own tasks. So rather than a standard blueprint that we're going to get like an event tick or whatever, now this blueprint is called as part of coming in here. So we're going to have this execute event. So we receive execute whenever we start going. We're going to want to set the blackboard value. So this is very similar to what we already know. There's a slight difference here. So this is there's a key selector object. This is really because we're part of this this whole setup, right? So because we're in the blueprint itself, we're in here, we're modifying things, and so we live in this space. It's not happy that I'm not setting values, and so we can modify directly. So what we get instead of a string is we actually do get the key selector. So I'm going to go search, and I'm just gonna call this variable key, and the search for the blackboard key selector. And then that sets the key that we're going to set, and I'm going to make sure that's a public variable so we can see it attached to our task and something we can modify. And then similarly, I'm going to give the value, and the value in this case is going to be what we're resetting it to. So we know we want that to be an actor. Just scroll down. Oops, missed it. And that's going to fill in our value here. Go ahead and compile that so it stops complaining. Then the last thing we have to do is we have to tell it again what we're doing. So all tasks have 3 possible returns. They could be in the middle of running, they can succeed, or they can fail. And so we're going to call this finish execute, and we're going to tell it whether or not we succeeded or failed. So if we had a long running task in here, we could let that continue to run to some degree, and the behavior tree would sort of continue to go, right, and then finish when it finished. Okay, so now we have this new task. Let's go ahead and change the name of it. So it was created in the same place as everything else. We'll call this BT task reset value. It has a name similar to some of these other guys. Now, based on that, we can say, look for this reset value. Okay, so let's set the values then. So it immediately selected patrol point. That's not what we want to set. We actually want to set the target, and we do want to set its value to none. So we sort of want to unset that value. So now we'll move to, we'll wait for 2 seconds, and then we'll reset the value here with the key as target and the value as none. Okay. So let's test that out. Let's see what happens. Okay, so our goblin is over there. We'll see when he decides to see us. Now it looks like he's no longer on the path, so he's definitely seen us. He's going to move in. He's now pretty close to us, waiting for a couple seconds, and then he moves on. immediately moves back to his task. So he turns around immediately. He no longer sees us. But if he were to see us again, and there's a certain interval on how quickly they'll respond to their sensing that we can set, and we can take a look at that. But based on that, now we have kind of this attack sequence set up. So let's go take a look at the some of the things in the pawn sensing. So the sensing interval here is 0.5 seconds. So it takes half a second before any updates happen. So if we have reset, because we've reset the object, it would take potentially up to a half a second before we'd see him again. We can also set some other things like the sight radius. How far can you actually see? So this is set to 50 meters, which is pretty reasonable distance. It's probably the entire level that we have here. So as long as you're not being blocked by line of sight, so you can actually hide behind rocks and things like that. As long as you're not being blocked, then he'll be able to see you and go to that location. So before I leave this section, I did notice at least one small error relative to the book, and that is that we're seeing a pawn, but we're not necessarily making sure that it's the player in this case. So we do want to have it be the player. Now we could have a similar kind of thing to say, look for another goblin, see if it's the goblin, an ally that's in trouble, and we want to go help them out or something, or see if something's going on, right, that we care about, or you can have both allied responses and enemy responses, and consider those kinds of interesting advanced behaviors. But of course here what we're looking at is we need to just at least make sure that we're only attacking the good guys, or I mean the bad. We are the bad guys. We want to make sure we're attacking the good guys. So that's what we need to ensure here. Otherwise we'd end up attacking other enemies as soon as we added them in. So certainly, don't forget to do that, and as always, reference the book. Make sure that we're all squared away.